This is H2O2 from H2O. This is a demonstration of the H2O2-PWM PTH V2. We're covering the assembly of this PCB. The first component is D10. There's a band here. D10 is a diode. It has a band, and that band is also a line on the PCB board. D10 is located here, and here's the band. So the first thing we want to do is to push it, the band side, into the hole that's on the band. It's a little tight, and so you'll need to work it in like that, and then pull it back out. You may have to rotate it slightly. And on the other end, opposite the band, push it in that hole and spin it until it goes in. And now you're going to need to bend it. The bend needs to be tight, but not so tight that it snaps off from the component. I'm going to pull back about 1/16 of an inch. And I'm going to bend it about 20 to 30 degrees. And then I'm going to pull it another 1/16 and bend it again another 30 degrees. And another 1/16 until it's 90 degrees over. And there'll be a slight bend. And then we want to pull it out and bend to the other side, to the striped side, using the same process. Now the two bends need to go parallel to each other, and so you may find it a little difficult to use the striped side hole, and you can move it to the other hole, which I probably will do. 1/16 of an inch. And about 30 degrees, and 30 degrees, another 1/16 of an inch. Okay, so it should look something like this. Something like that. Okay, so here's the stripe right here, my thumbnail. I'm going to pull it out. Line the two stripes up. And I'm going to gradually just work it down. Don't want to bend anything. You want to keep those wires as straight as possible so that they don't bind up. Now we're not going to push it all the way down to the board. We want to leave a little gap. And that'll allow us to lean it over a little bit. Okay, so once you get it down to that far, that's where you'll stop. Now we'll take the two leads in the back, bend them at about 20 degrees, 30 degrees, like that, and now that can't fall out. So again, stripe on the board, stripe on the component, they line up. Okay. So the next thing you want to stuff in are the capacitors, the non-polarized capacitors. So they Non-polarized capacitors don't matter which way you put them in. So we've got C1 here, C3 here. It's the light tan one. C1 is brown. C6, C13, and C10 are all the same value. And we have C11, and C14, which are the same value. And then C12, this blue one over here. That is a different value from C10 and C14. So you pass those through and then bend out the wiring so that they maintain their position. Now the paint on the components needs to not be stuffed down inside the hole. If you do that, then the solder will not flow around the lead and secure it correctly. So there needs to be a little bit of metal showing so that the solder can flow up to that point. And that's true for the resistors and the capacitors. Any component really that has paint on it. Okay, now we want to stuff the electrolytics. So C2 and C4, these are polarized. Look like little batteries. And on them they have a stripe. And inside the stripe there's usually a mark that looks like a little negative sign. The stripe side is always the negative side in the canned capacitors. So these are through-hole capacitors. They're actually a little metal can with insulation on them. And then on the end of them they have a plug, usually some sort of rubber on them. So that negative sign goes into the negative position on the board. The positive positions are marked on the board. C2 is this circle right here. The positive is close to C15, a little tiny positive mark there. Both the positive leads face each other on C15 and C2, so the stripes need to face away. They shouldn't be pushed all the way to the board. There should be a fingernail's width or so that they don't, when the temperature changes on the board, they don't get pull on their leads as the metal changes shape. So bend those leads over, and when we flip the board over, they'll kind of hang there, and then we'll solder them in place. That's a little later. Okay, we want to stuff in C2, that's C2, and then C4. C4 is located here. It's very close to U1. It's between U1 and U3. The positive side is real close to R27. So the stripe will go away from that side. fingernail's width. Hold it there. Okay. Then we want to stuff in C15. C15 is located right next to C2. It's at the edge of the board. And the positive side is facing C2. The negative side is pointing towards the mounting hole right here. The stripe is pointing towards the mounting hole here. Okay, so that concludes all the capacitors, I believe. So the next step is to solder these in place. So it's time to solder. You need your soldering iron turned up to about 700 degrees Fahrenheit. You need your solder, you need your iron. The basics of soldering is that you apply the heat to your board and your component and you add solder. You don't try to put the solder on here and then try to apply it to the board. That doesn't work. You always want a clean tip. And that's done from shocking. Shocking is a technique where you use a sponge with moisture on it, preferably distilled water, and you run it across that and it flashes the steam and pushes off all the oxidation. So we want to heat both components, the board through hole and the component, and then melt the solder into that. Solder should flow down into the hole and actually pass through the other side, forming a strong bond. It's a little difficult to see on the C4 because the component covers that up. Okay, so I believe this is like C. C12. You don't have to do them in this order. Keep your tip clean. Keep any debris off of it. Helps to have your board mounted good. For demonstration purposes, I've got it so you guys can see good, better at least. Okay. Okay, from the other side, you can see the solder has flowed up on its leg on both pads. That's a good solder joint. So you just want to repeat that. Keep your tip clean. I'm adding in a helping hand just to keep that board a little more stable. Another technique is to actually tape the board down to the table. Okay, and we'll flip it over and we'll inspect all the solder joints, make sure the solder got all the way through and all the components. If it didn't, you can touch it up from the top side. Okay, you also want to inspect to make sure you soldered everything. I missed one. Okay, and then you want to cut off all the leads. And you want to leave a little bit of a mound. You don't want to cut so close to the board that you damage the board. I've seen people use toenail clippers, fingernail clippers for this. This is a pair of cutters that cuts close to the surface. Make sure you've got eye protection. Okay, so clean up. We're going to install L1. L1 is not polarized. It doesn't matter which way it goes. L1 is located right on the edge here, very close to D10. And if you look at the pattern, there's an oval all around both of the pads, and then there's a circle around the pad that's towards the center of the board. What that signifies is that you're going to stand the component up, and you're going to take the lead, and you're just going to gently use your fingernail to bend it so that it's arched, curved, and then it goes straight back down. And the little circle on the board signifies where the component goes straight in, or where the paint of the component, not the arch. And so we pass that through there. And then we want to leave that fingernail's width again from the paint. Bend it over. It can't move. And I'm going to solder this one because that's kind of a long lead. Always clean your tip. And then cut the leads off. Okay, now that you got some soldering experience, it's time to put the ICs in. Okay, so there are 3 ICs. U1, it's the big 14 pin, that's this guy here. U2, it's a power regulator. And U3. They're all polarized and they all need to go in a specific way. Okay, this notch signifies the end that pin 1 is on. Pin 1 is always below that. And then you take the pin numbers and go the notch, pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. U3 also has a notch. And pin 1 is right below it. And 1, 2, 3, 4, 5, 6, 7, 8. So we want to set U1 on the board. And on the board you'll see a square pad in one of the corners, close to the www. And an asterisk star off from that square pad. That's pin 1. So we want to set the chip down so that the pin 1 and the notch line up. We're going to have to prep this a little bit because the pins are pushed out a little bit. They're splayed out. We need to take and just gently set it up on the pins and then rock them till they're flat. Do that from both sides. When you're looking down from the end, that they all go straight down now. Then we're going to set that in. Line up pin 1. Should just fall right in. You got it right. Okay, so the notch. Pin 1 is the asterisk, and pin 1 is also the square pad. Okay, once we got it in, then we'll put our thumb on it and roll it over. And take pin 1 and bend over the pin at about 45 degrees. And then bend over the pin that's diagonal from that, or pin 8, the same way. And you want the pressure on the back side to keep it so it's flush. That'll keep the pin or the chip from falling out. Okay, then we want to load in U3. It's the same situation. I'm going to bend the pins, be gentle with this. You can go too far, push too hard. You can do each pin individually, but I find that they get a little lopsided when you do that. Alright, so pin 1 on the chip. U3 is up here. There's a JP8 underneath U3. We're not going to use that. So pin 1, square pad, asterisk next to it. Line up the chip, the notch, pin 1's below it. Sets right in there. Put your finger on it, flip it over, and pin 1 at about 45 degrees, and pin 5 at about 45 degrees. And keep it in the spot. Okay. U2. If you stand U2 up and face the black into the board, into the center of the board, the back plane creates a line. That back plane has a line on the board inside the footprint for the part. So you've got the pads, and then a line, and then an open spot, and then another line. That line, or those two lines that form that box, is the heatsink. So we want that to fit in like that. Now, you don't want to force it all the way to the bottom, because it makes it too tall. We want the regulator to lay over, so when it's finished, it's going to look like this, with the pins being bent down and going into the board. So we need to pre-bend those. So we want to bend at about 3/4. We want to start bending, and we want a gradual bend. We don't want a 90 degree. something like that. And those should fit down inside those pads on the board, pass all the way through the board, stick out the other side just a little bit. You don't want this heat sink touching anything. It should be sitting there free. Should be a gap all the way around. Okay, so we want to flip it over and we want to solder. I'm going to pull U2 out. I'm going to solder the two chips. Flip it over. You just want to solder pin 1. And that's U1, and then we're going to do pin 1, U3. Okay. And we're going to make sure that it's still flush. And it is. And we're going to go back and we're going to solder the pin opposite the corner of pin 1. So pin 8 on U1. And pin 5 on U3. I'm going to check it again. Make sure it's all in the same spot. And at this point, if it's not, if it's sitting lopsided or sloped, you can heat these two pads with your finger on the back side of the board, right on the chip, but to make sure you're not touching any of those pins. And you can go back and forth and heat pin 1 and pin 8 back and forth really fast between the two, back and forth, back and forth, back and forth, and you can walk it and get it flush again to the board. You can do that with any component. Alright, then you want to finish up the solder on all those pins. Just be methodical. Heat the through hole, heat the pin, add the solder. Okay, that's U1 and U3. Now we want to put in U2. It's already been pre-bent. We want to set it in there. Heatsink should be facing up. Okay, at this point, probably the easiest thing to do is throw a little tape on there. Use masking tape, don't use Scotch tape. Scotch tape creates static. Or maybe you could just tie it with a rubber band or a piece of wire. Might work. I've got some fine wire here. Okay. So So that's just a wire to keep it in place. It's doing pretty good. Tie wrap would work. One of those bread tie wraps with a little metal inside of it. Flip it over, inspect your work, make sure the solder flowed all the way through. Looking pretty good. So the two holes that are just outside the U2 box are for the fan. The square one is the positive, and the round one is the negative. So you may be hooking up a cooling fan, and that's where you do it. It runs on 12 volts at that point, but it runs through the filtering system, so it cleans up some of the spikes that we get. So at this point, you should look something like this. So the next step is to add the resistors. And I think we'll start with the fixed resistors. Okay, so you'll stuff the resistors in the same way you did L1. You'll bend it over and have the leads go in parallel. So we stuff R11 here with the R6 is very close to C4. It's up next to the heatsink here of U2. We want to make sure that that resistor doesn't touch that heatsink. So we want to lean it a little bit away. Something like that. Okay, so on the back we've got quite a bit of soldering to do. You've already seen me solder the capacitors. These are done the same way, so I'm going to spare you the time to watch me do that. When I get done, I will cut them all back, and then we'll start on the variable resistors. They are 1, 2, and 3. One quick note, it's probably best that you solder a few in one area and then trim them and then work off into another area. Keep doing that, that way you're not fighting all this, all these leads. That'll save you some headache. Alright, so the placement of the variable resistors. Here are 1, 2, and 3 are marked on the board. They each have 3 pins. They go on the component side of the board. It should look something like that. Now they should sit completely flat to the board. So if you put your finger on them, or one at a time, put your finger on it, flip it over, splay that out good, and make sure that it doesn't fall out. It's still going to be a little loose. You'll solder one pin, get it right where you want it, and then we'll solder the rest of the pins. So that's VR1. Okay, so this is where VR2 goes. It's in the corner. Do the same technique. And then VR3. So VR3 goes in between them. Now VR3 has some other holes in that area on the board. You want that same pattern. The 3, it should all square up when it's all installed. You should have straight flush lines here, flush lines here. It should sit flat. Should have an equal distance between each of them. It should look something like that. Okay, we're going to flip it over. Now we're only going to solder one pad for each of those components. I like to do the middle one, the one that's offset. So I'm going to touch this, just a little bit of solder. Get the middle on each one of them. Like that. Then you flip it back over and put your thumb or your forefinger, something on there to make sure that that's flat. I'm going to reheat that pad. So right now I'm on VR1. I'm pushing VR1 flat to the board. I'm going to reheat that pad. Make sure it's flat. If it moves, that's good. Means it wasn't right in the right position. Do a visual on it. Make sure it's in the right spot. Go on and do VR3, the one next to that. Okay, that one looks good. And VR2 in the corner. Looks good. Okay. At this point you should have equidistance and they should be centered. Like that. Okay, then we're going to finish off the soldering on VR1, 3, and 2. And your tip. Once you've soldered the first two and they solder solidifies, you want to catch that third one again just to make sure there's enough solder in there. Okay, that's the 3 variable resistors. Okay, you want to trim those off as well. Okay, so J3, not to be confused with JP3. J3 is over by the variable resistors, and this is the function that allows you to disable the pulse width modulation and go to 100% duty cycle. When it's shorted, it provides that function. So in the kit, you're going to have some of this material. They're pins, and they're made to break on the black in between each of the pins. So what you want to do is bust off 2 of those. So we have something like that. And that will fit down in the holes for J3 and look like that. Now this one's a little tricky because if you're touching the pins, you're going to burn your fingers. So what I usually do is flip it over onto something that's touching those pins. Something like that. Now if you just solder one of them, you can adjust it. So I'm going to solder pin 1. Okay. I'm going to make sure it's where I want it. It's leaning a little bit. So if I touch the other pin, I can adjust it and I won't get burnt. It's looking pretty good. It's flush to the board. Okay, then we're going to touch up the other one. So this is pin 2. Let that cool, solidify. And I'm going to just touch up pin 1. Make sure there's enough solder there. Okay, so J3 has a shunt that we stick on. It looks like this. If they're both connected, it disables the current limiting and makes the duty cycle 100%. Normal operation, we want to leave 1 pin hanging. You can take this off completely, or you can store it here, store it somewhere else, it doesn't matter. This is just a convenient place to stick it. So that's normal operations right there. Okay, you want to inspect to make sure that none of the tops of the resistors are leaning against any other resistor or capacitor, especially not touching any metal. That'll cause shorts and the circuits won't function properly. Okay, let's talk about cleaning the board. couple ways you can do this. You can use isopropyl alcohol. Clean the board. This will remove any flux that's in your solder. I use no clean solder, and you can leave the flux right on the board. I don't prefer doing that. I prefer cleaning things up. It does dissolve with alcohol. If you're using a water-based or water-soluble flux, you need to wash it. And some people think, oh, you can't wash circuits. No, that's not healthy for them. Nah. Little dish soap, 150-degree water, acid brush, get it all foamy. Do that a couple times, rinse it really good. Repeat the process a couple times. And then dry the board good before you turn on the electrons, because that's what'll damage it. When you got conductivity and electrons moving around, you make traces out of the calcium or the iron in the water, which causes artificial traces. And that's where you get into trouble. So you want really clean water, distilled to be preferred on your final rinse. Doesn't have to be when you're washing. And then dry the board good. Looking pretty clean. Okay, so the next step is to test the board. So we'll get into that later. This is H2O2 from H2O, signing out.
Music by Kevin MacLeod.